So this is the review for the test. At any point, you're allowed to pause the video so you can complete the problems, and then play the video so you can see the answers to the problems. So the first section of this study guide says you're interested in finding out if students at your school think that the Fine Arts program are receiving enough funding. So you decide to 1, use a written survey that you gave to people sitting at your lunch table. So what type of sampling of this situation? What is this? This, problem 1, is a convenience. Because they're convenient to you. They're easily accessed. Problem 2 says you put a table at the entrance to the cafeteria with a sign directing students to complete the survey if they want to and drop it in the box. This is a self-selected, meaning that they can or cannot do the survey. It's up to them. Problem 3 says a randomly selected students from each of the 4 grades. This is a stratified survey. 4 says you ask all the juniors and freshmen. This is an example of a clustered survey. And 5 says you put all the names in a hat and draw half of the names out to ask. This is considered a random survey. 6 says Dr. Jones wants to see whether the gender of members in the tribe of the Amazon plays a role in the order in which they are served their meals. Is this an observational study or an experiment? This is actually an observational study. So nothing is being changed. Oh, I'm sorry guys, I wrote it in the wrong question. So 6 is an observational study. Now 7 says that Dr. Jones wants to see whether the monkeys in an area grow larger when eating their native diet or when they are given manufactured monkey pellets. First, it wants us to identify as an experiment or an observational study. 7 is an experiment because you're actually changing something. Now, the second part of the question asks for us to identify the treatment group, control group, and the actual treatment. So the treatment, I'm going to change colors so you can know I'm writing something else. The treatment are the monkey pellets. The treatment group are the monkeys that are given the pellets. And then the control group are the monkeys that are given their natural diet. Problem 8 asks us to draw a normal curve for a normal distribution with the mean of 30 and a standard deviation of 5. Label all the areas under the curve. So it wants us to draw the normal distribution curve. So I'm going to draw my line and then draw my curve. Remember, the line that's directly in the middle is our mean. And then we're going to have 3 lines to the right and 3 lines to the left. Each of these lines represents a standard deviation away from the mean. So to the right, our standard deviation of 5. So my next line is going to be 35. The one after is 40, and the next one is 45. So we added 5 to go to the right. To go to the left, we're going to subtract 5. So 30 minus 5 is 25, then 20, then 15. It also wants to label the percentages underneath the curve. So I know that this is 34 and this is 34 because remember that a normal distribution curve is symmetric on both sides. The next one is 13 and a half. Followed by 2.35. And lastly, this little bitty section at the end is 0.15%. So that's a normal distribution curve with the mean of 30 and a standard deviation of 5. Now, questions 9 and 10 asks us to get the percent of the area under the curve represented by the shaded region. I know it's really hard to see the shading, so just make sure you're shading the right area. It's this portion, that portion, there, and then the little bitty portion at the end. So I'm going to take all the percentages of that curve. Oh, I'm kidding. Sorry. It's really hard to see. So it's only just those 3 portions. So I'm going to take this first portion, which is 0.15%. So I'm going to take 0.15, add it to the next portion, which is 13.5%, and add it to the next portion, which is 34%. I'm going to add those 3 numbers up, and you should get 47.65% as your final answer. Problem 10, the shaded area is there. Those 2 areas and the little area on the end. So on this problem, I know that the 2 smallest portions are 0.15%. So I'm going to add 0.15 twice. Now these 2 areas are 34% each. So I'm going to have 34 plus 34. When you add those up, you should get 68.3%. Problem 11 says 100 students out of 1,200 at a school were surveyed. 14 said that they had an after-school job. They want you to predict the number of students in the population that would answer similarly. So I have to set up a proportion. 14 out of the 100 students that were surveyed answered that they do have an after-school job. But they want to know how many do you predict will have an after-school job out of 1,200 students. So we have to set up a proportion and solve for x. So your final answer, you should get x equals 168 students. Remember, you have to round if it comes out as a decimal place because you can't have a 0.6 part of a person. So problem 12, it says a normal distribution curve has a mean of 42 and a standard deviation of 3. It wants us to draw a normal distribution curve that represents this problem. So I'm going to draw my curve. Remember, the mean is the point in the middle, which in this problem is 42. And our standard deviation is 3. So I'm going to add 3 to each line to the left, or to the right. So I'm going to have 45, 48, and 51. And then I'm going to subtract 3. So I'm going to have 39, 36, and 33. Part A asks which values lie between 33 and 45. So it's going to be this area, all of that area added together. Since 33 and 45 both land on a standard deviation line, then I don't have to use the calculator for this. I just need to add up the percentages of those areas. So it's going to be 34 plus 34 plus 13 and a half plus 2.35, which should give you 83.85%. Part B asks what percentage lies above 48. So that's going to be this section and this section added together. So those two sections are 2.35% plus 0.15%, which would give you 2.5%. Now, C says what percent lies below 35. Roughly sketching, 35 is about right here. So since it does not lie on a standard deviation line that we know for sure what the percentages are, we're going to have to use a calculator to calculate this. So in your calculator, you're going to do second distribution, go to number 2. Remember, it has to be the normal CDF. Once you get there, you've got to put your lower bound, which for this problem is going to be negative infinity. So it's going to be negative 1e to the 9, because it can be below 35. Now our upper bound is going to be 35, so you're going to type in 35 in for the upper. And then the next symbol you see is going to be the mean, so you're going to type in 42. And then the fourth symbol is the standard deviation symbol, which in this case you're going to type in 3. You're going to hit paste, click enter, and then enter again, which should give you a decimal point that is really, really small. But remember, it's asking for percentages, so when you change it to a percentage, you should get 0.98%. The next problem says that the high temperatures for days in January are normally distributed within the mean of 38 and a standard deviation of 5 degrees. So I'm just going to plug in my numbers into this normal distribution curve. So the mean is 38. So when I plug in my numbers for the standard deviations, the first problem says, what is the probability that the high temperature for a day will be almost 46? So 46 is probably about in here somewhere. So that doesn't lie directly onto the standard deviations. So I'm going to have to use a calculator for this. When you plug in your upper bound, or the lower bound I mean, you should plug in negative infinity, because the most it can be is 46, so it can be below 46. Then for your upper bound, you should plug in 46 with the mean of 38 and a standard deviation of 5. When you paste that into the calculator, you should get 0.95. Remember, it's asking for probability now, so we don't have to change the decimal points. Problem B says, what is the probability that the high temperature will be at least 36? So that means my line's going to be about somewhere in this general area. So it means at least 36 means that my lower bound is going to be 36, and my upper bound is going to be positive infinity. So once you plug those into the calculator, you should get 0.66. The next section is what is the probability that the high temperature will be between 32 and 44 degrees. So that means you're going to plug in 32 in for your lower bound and 44 in for your higher bound. So once you do that and paste it into your calculator, you should get about 0.77 probability. The next problem says that the mean of the age of reading the War of Worlds is 18 with a standard deviation of 1 in the city of Fargo, North Dakota, that has a population of 10,000. So if I fill in my little chart, I'm going to have 18 as the mean, and then 1 standard deviation away from left and right should give me this. A asks for how many people would have read the books between the ages 17 and 19. So 17 and 19 is here and here. So those lands on the standard deviation. So I can just use my percentages to find the probability. So in this case, it's going to be 0.68%. But the question asks for how many people would have read the book. So from here, I have to take that 0.68% and multiply it by the population of our city, which is 10,000. When you plug that into the calculator, remember that you can't have like 0.6 part of a person, so you have to round it. So you should have gotten 6,800 people as your answer. Problem B says how many people would have read the book between the ages of 16 and 20. So that's here and here. So I have to add 13.5 plus 34 plus 34 plus 13.5. When you add those together, you should get about 0.95. You're going to multiply that number by 10,000, which gives you roughly 9,500 people. Part C asks for how many people have read the book between ages 15 and 21. So that's this area and this area. Now, since I'm including a whole lot of this normal distribution curve, I can actually choose to subtract rather than add. So I can take 100 and subtract 0.15 2 times, because this is the area that's not being included in the actual percentage. So if I take 100 and I subtract 0.15 2 times, I should get 99.7%, but we want it as a decimal. So I'm going to have 0.997, and I'm going to multiply that number by 10,000, which should give me 9,970 people read the book between ages 15 and 21. The next page says that the average of the tests in my class and Miss Myrtle's class were normally distributed on the last advanced algebra test that we gave. The average in my class was 86 with a standard deviation of 3, and the average of Miss Myrtle's test was 82 with a standard deviation of 4. If you made an 88 on my test and your friend made an 85 on Miss Myrtle's test, who had the better score? So my z-score, I'm going to use the formula. The z-score equals x minus the mean divided by the standard deviation. So when you plug in numbers, you should have gotten the z-score to be 0.667. When you plug in the numbers for your friend's z-score, you should have gotten 0.75. Now you have to decide who did better, you or your friend. To determine who did better, you want to pick the person who was the furthest away from the mean with the numbers to the right. So in this case, the person who did better was your friend. Question 16. It says, given these test scores for the class, find the mean, median, and mode. Alright, so I had to grab the microphone so you could actually hear me. So problem 16 says that given these test scores for the class, to find the mean, median, and mode. Mean, median, and mode is just what central tendencies are talking about. So remember that the mean is the average of all of the test scores divided by the number of test scores that you have. So I'll have to add all of these numbers together and divide by the number of test scores, which was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when you put those into the calculator, you should have gotten 85 as the mean. Remember that the median is the number that's in the middle when the numbers are in order from smallest to greatest. Now, since we have an even number of numbers, we have to take the two middle numbers, add them together, and divide it by 2. So when you do that, you should have gotten a median of 88. And the last central tendency that they want is the mode. Now, the mode is the number that is listed the most often, or occurs the most often. In this case, the mode is 90. And remember, you can have more than one mode. But if only every number is listed the same amount, then you do not have a mode. So for this problem, the only mode we have is 90. Now, part B says to use the mean plus or minus 3 standard deviations to test the outliers for this list of numbers. Remember that you can use your calculator to find the standard deviation. So if you use your calculator, you should have gotten the standard deviation to be 15. So you're going to take 15 and multiply it by 3. So when you multiply 3 by 15, you got 45. So you have to take the mean of 88 and add and subtract 45 to that number. When you do that, your intervals for determining if you have any outliers or not is 40 to 130. If any of your numbers that are listed under the test scores is between or outside of 40 and 130, then you have an outlier. The smallest number we have is 50. So 50 is above 40, so that's not considered an outlier. And the biggest number we have is 106. 106 is less than 130, so it's also considered not an outlier. Now, problem C says if you take 50 and 106 out of the list, are there any outliers with their either calculations? So if I take 50 and 106 out of the list, my new mean is going to be 86.75, and the new standard deviation is going to be 7. My interval now changes to 65.75 to 107.75. Now, if we look back at our test scores, we notice that none of our tests go below or above this range. So the answer to C would be no. Question D says, which is a better measure for the center of the original list? Okay, so part D says, which is a better measure for the center of the original data? Because we have two numbers that are really small or really big compared to the other numbers, then the best measure for the center of the data is going to be the median. But if you throw out the really big number and the really small number, then a measure that could work would also be the mean. So let's look at problem 17. 17A says, what is the margin of error when you survey 8,674 people? Remember that the formula that we use is plus or minus 1 over the square root of n, where n is the sample size. So if you plug in 1 divided by the square root of 8,674, you should have gotten plus or minus 1.07%. Part B says that if you survey 923 people with the 81% yes response, what is the range of the likely outcomes? So this wants the interval. So remember, you need to find the margin of error, which is 1 over the square root of 923, which gives you plus or minus 3.29%. From here, you're going to take 81 and subtract 3.29%, which should give you 77.71 through 81 plus 3.29, which is 84.29%. So that's my interval, or the range. Now, if you have a margin of error of 3.2%, how many people did you survey? So that means you're going to plug in 3.2%, change it to a decimal to have 0.032 equals 1 divided by the square root of n. Remember, we are solving for n. So I have to multiply both sides by the square root of n, so I'm going to have the square root of n equals 1. I have to divide the 0.032 and then square that. So n, or the sample size of this problem, should give you 977 people.